what is observability? I'm sure you have your own notions, but this is the definition in the course. Observability is the ability to measure the current state of a system by examining its outputs. So any system, obviously we're talking about IT systems in this course primarily. So any inputs may go into a system, but you may not know what's happening in that system if the outputs are not visible. So you may get access to the system's outputs through telemetry or other means monitoring and looking at the system. But if they're not available, you won't know what's going on. So observability makes sure that outputs are visible so you can understand the state of the system internally, according to the ideas of observability and looking at the outputs. Exactly how can the internal state of a system be known? Well, with proper applications in place, forms of communication called signals are emitted and that provide quality information and monitor the internal state of the system. That's, again, an observable system. So examples of such outputs could be metrics, events, logs, traces, any data that is produced from the system that you're trying to observe. The data is emitted and then collected from these signals. The collection is and the process of emitting and collecting is called telemetry. That's not a formal definition, but that's in truth what it is. I can tell you throughout my career, I've had plenty of cases where, in fact, I remember one where I had a hardware manager. I was the VP of an organization, and we were building a new integrated circuit, and it was a complex, protocol being implemented within the integrated circuit for signaling transfer systems. And unfortunately, the design did not include the ability to monitor the state transition in the protocols. And by the time the integrated circuit was ready, we couldn't really debug it because we hadn't put in observability points. At least I was, as the VP, disappointed about that because that was actually part of the specification. So as you can imagine, I wasn't very happy with my hardware manager at the time, but fundamentally that's an example, right? If you don't have ability to see what's going on inside that box, inside the system, it makes it pretty hard to work with, especially when things go wrong. There are actually, they talk about 3 pillars of observability that will be discussed in the next module, actually in more detail. But the 3 pillars are metrics, logs, and traces. And on top of that, there's this acronym associated with availability called MELT, which also includes events. So these are the essential data types for observability. When you instrument everything and use MELT to develop you can develop a fundamental understanding of connections, relationships, dependencies, detailed performance, health. That's what observability is all about. So there's a brief definition of each of these MELT acronym here. So metrics are the values pertaining to a system's application at a certain point in time, various types of metrics. They could be calculated from other data, maybe something available on a dashboard or coming through an event or a log. Events are specific sequences of occurrences that take place within a system being monitored. So events usually have an association with time and time, relative time, absolute time. Logs are the original data type. They've been around the longest in terms of IT usage. In their most fundamental form, logs are essentially lines of text that a system or application produces when certain code blocks are executed. So those are usually driven from the code itself. And traces, or more precisely distributed traces, are samples of causal chains of events or transactions between different components in a microservices ecosystem. In fact, it doesn't really have to be microservices, but definitely in different parts of a distributed system. Traces are particularly useful to see the time sequence of events as data and activities are occurring across a distributed system. So why is observability important? I think by now you're probably getting a good idea, but there's a lot of factors. Observability provides insights into the functioning of a system and enables teams and individuals, for that matter, to make informed decisions about the system's health, performance, helping to ensure overall reliability and availability of the systems. So the point is, knowing the internal state of a system can lead to better understanding, so better insights into system behaviors, monitoring system performance. You might not see degradation of performance if you don't have good observability. Can help troubleshoot problems, provide real-time monitoring instantly, rather than having to decode, indirectly. Increased security in a number of security use cases. Observability is definitely invaluable. Being cost effective, because you can see how different parts of the system are being used, and or optimize your system according to cost when you know that. And in general, it helps with scalability as well. It's somewhat the same reason you can see where resources are being running to their end of the limits, and possibly decide how you're going to scale those components of your system, either through things like horizontal or vertical scaling, adding more capabilities. You'll know observability will help you know when to do that, and also where you might need to do that. So again, why is it important? One-liner here from Joseph Pratt at Open Source Engineering. He said, one of the important things that observability enables is the ability to see how your systems behave. So that's yet another flavor of a definition, if you like. Observability is particularly important when you're looking at complex distributed systems. And these days, most modern systems are like that. They're typically not just one simple system. They're usually, combinations of systems that are interacting with each other to provide a service. Systems have become effectively inherently complex. And there's, if you like, white space in the area of integrated visibility, meaning if you have systems interconnected, and if you don't have visibility on how they're interconnected and how they're ordered and what the functions are, it may become difficult to visualize how these things are integrated, especially in real time in a real operating service. There are certainly a lot of performance impacts that can directly affect the business. You certainly do want to understand performance, things like slowness. There's a statement here, slow is the new down, meaning that from a business point of view, it's been proven that a slow response time to users can certainly affect your business. Walmart, for example, found that for every 1 second improvement in a page load time, sales conversions increased by 2%. So there's a clear relationship there. Now, 2% doesn't sound much, but when you're looking at a large organization like Walmart, that's a lot of money. And similarly, Mobify found that each 100 millisecond improvement in the homepage load time resulted in a 1.1% increase in conversion. So the little chart here on the side just pretty much does the same thing. When you've got faster response time, you're getting a higher conversion rate. When things are running slower, then it's a lower conversion rate. So keeping a track of your performance has a direct effect on the business. And in particular, you have to have pretty decent fidelity and accuracy. Otherwise, even small incremental changes can have a pretty big effect on your business. If you only had traditional monitoring without observability, meaning there's going to be some things that are not visible, or maybe the tracing capability is not visible, you'd have missed changes that could be hiding problems. State changes aren't tracked. You can't really tell which resource is serving which workload, so it's pretty much impossible to deal with in real time, at least, where a lot of indirect debugging, and that could be difficult. Frequent changes can break tracking. So if resources spin up and spin down, which does happen pretty regularly in modern operating systems, changing identity with every change state, right? You can have different parts of your system serving different parts of the workloads, and that can change over time. Too much aggregation can lose detail. So over aggregating hides important variations, making data useless. So in other words, if you don't have insights into specific components, then you won't really know, where to look for problems or improvements. And last but not least, need, speed, and scale must handle high cardinality of data, high number of combinations of data. Must be able to retrieve it fast and make sense of it in near real time. Definitely a key requirement for observability. So here, as continuation of the point, why does traditional monitoring alone not suffice in these more complex modern systems? So simply put, complexity. When you've got a network or topology of components to provide the service, individual monitoring of one component is not going to give you the complete picture of what's happening. Elasticity, where you've got ephemeral components going up and down, depending on workloads and varying traffic demands and so on. Again, it's pretty hard to keep track manually and with manual monitoring what's really happening. And transients, where you've got some resources are pretty short-lived. They're only being used at the time service is being used, and then perhaps taken down when they're not used. So keeping track of what's up and what's down at any point in time, not just from an availability point of view, but from an actual operating system point of view, would be pretty hard to do without observability. So bottom line is complexity, provides deep transaction visibility. Varied telemetry is hard to connect and interpret in that case if you don't have good observability. Elasticity is the rapid scaling changes that, and things like entity counts, metadata drives up high cardinality data and analysis costs. And transient, where you have short-lived resources disappearing quickly, making it hard to track workloads and correlate the data across changes.